In this video, I'm going to take a look at the volume changes in the left ventricle. Um, Before we do that, though, we need to add a few things here. I'm going to just add an arbitrary line in a half second, um, just a subtle line that separates ventricular systole from ventricular diastole. We know ventricular systole is the ventricular contraction, and ventricular diastole is ventricular relaxation, or synonymous with ventricular filling. So our x-axis here at time equals 0 begins at systole, or we're going to call this volume at time equals 0 the end diastolic volume. So we can imagine we would have a full ventricle at this point, and we're going to consider a full ventricle to be 140 milliliters of blood. And so initially, when the left ventricle begins contraction, we get quite a bit of blood that leaves the left ventricle. And then in time, the amount of blood that's being pushed out of the left ventricle is going to slow down a bit. And this is going to be what the graph looks like. And so this, this difference between when the ventricle begins to contract and when the ventricle ends contraction, this difference is going to be what we call the stroke volume. And the stroke volume, to calculate stroke volume, is going to be the end diastolic volume minus the end systolic volume. And the end diastolic volume we see here is 140 mLs. And the end systolic volume here is about 70 mLs. And so our stroke volume in this situation is 70 milliliters of blood. Moving on, as we enter diastole, or ventricular filling, what's going to happen is we're going to get initially a rapid filling of the ventricle here. And this rapid filling is something that actually occurs passively. It doesn't occur actively. And what I mean by the idea that it occurs passively is that the atria is not contracting to push this blood into the ventricle. The atria is still relaxed, and all that's happening is the pressure change in the atria opens the valve between the left atria and the left ventricle, and blood begins to rapidly but passively fill the ventricle. Okay, so this this section of diastole we call rapid passive filling. As it fills a little bit, it's going to slow down, and we're going to get a section of this ventricular filling that we call slow passive filling. And so the same principle applies. It's still passive. The atria has still not contracted, but it's just filling at a little slower rate. And then as we move forward, we finally get the atrial contraction that really doesn't fill the ventricle that much. It just does this little bit of a notch here at the end of diastole, and this we're going to call active filling. Active because the atria is contracting. And let me just point out here that the slow passive filling phase has a special name. Slow passive filling is something we call diastasis, which is important because well, let's take a scenario. Okay, so this graph is a person whose heart is beating at about 60 beats per minute. But what happens if someone's heart rate is cranked up a bit? Maybe they just walked up a flight of steps, or maybe they are on a run trying to exercise and lose a little weight. Their heart rate is going to climb. But what does that heart rate increase really do to the cardiac cycle? Well, it's going to cut into this part of the cardiac cycle, diastole, the end of diastole. And this is quite important because you can see here that most of the filling of the heart or of the ventricle occurs at the beginning of diastole. And so as we cut into the end of diastole, we really have quite a bit of a buffer already set up. And so we're not losing a lot of our end diastolic volume with an increased heart rate. And as we cut into diastole, we're really just cutting into this period of diastasis. And diastasis is really, just the buffer in the left ventricular volume that we lose as heart rate climbs. I hope that makes sense. If it doesn't, please leave a comment below, and we can talk a little bit more about it. We'll go on to another video from now.